All right, can anybody verify that that's working as it should? All right, cool. Let's go ahead and get started. So again, as always, we seem to be a step ahead of all the lessons. So some of today is going to be review, but hopefully we'll dive in a little bit deeper with some stuff. So we're going to start with LINQ. Everybody remembers we went over LINQ before? No? Yes? I think we went over LINQ briefly before. So LINQ is just a library that has a whole bunch of really awesome helper methods. System.LINQ, so if you want to add it in, this is actually adds a bunch of extension methods to things. So if we have a dictionary of int string, I'll add 5 and enter this. Let's skip around a little bit. Two and 4, 4. One. I have a dictionary here, initialized with these values. Delete that for the sake of consistency. Actually, let's just add that. We've got all of these out of order, 5, 3, 2, 4, 1, all with their corresponding values and string. If we wanted to sort this, we could actually write our own loop to go ahead and sort, add these to a new dictionary, and then keep going until the whole thing is reduced to nothing and sorted properly. Or we could just use LINQ. So we can say, do for each. Key, and then value. Right now, if we do that, then we get it in the order that they were initialized in. If we want to sort this, then we can just simply say I commented this out. There's no order by sort, nothing like that, because our LINQ library isn't in there. Once we add our LINQ, oops, and all of a sudden we get a bunch of other things that show up in here. See all these generics in here that weren't there before? That's all part of LINQ. They're extension methods add onto this. So now I can do, oops, order by, and we pass it in a lambda function like I did before. Everybody remembers the lambda function. We'll go over that some more here in a second. And I always forget how to sort one works. Let me look at it. String key value parent. Oops, no. I always forget how this one works. I just did this the other day too. When Google comes into play. Oh. Oh, that's right. Oh, that's why. Oh, that lambda function was fine because I forgot to cast this. My bad. There we go. Because this doesn't return the dictionary, it returns an I-ordered enumerable generic type, which could be anything. So you have to cast it to the proper distinct type or explicit type that you want. So now if we do this, it's going to sort by key. And of course, it's going to throw an error. Oh, yeah. Here, we'll just do it here. You wouldn't ordinarily assign it back to it. Let's do it here. Over by X. So there, now it orders it by the key 1 to 5. And let's see if this goes over how to do the other way. No, it doesn't. Yeah, so then we just order by and reverse it, then we should get 5, 4, 3, 2, 1. Yep. And you could do it the same way with the value. Five, 4, 1, 3, 2. So it's ordering it by the value instead of the key. So LINQ actually provides a lot of other functions. So if we look at, that's not what I want. Trying to jog my memory what that was about. No, it's not really going over it, but yeah, okay. So just certain, this is actually really good to read through to get a better idea of what it is. It adds a bunch of, I was hoping to get just a list of the methods that it adds, but you can see them here. All these extension methods, select many, sequence equal, single. We did, you just pass in a lambda function of what conditions you should skip on or elect on, or like they even have conversion functions that help you convert one data type to the next, one enumerable type to another. Really helpful, but anytime you need to sort or convert data enumerable types, then LINQ is a good way to go. We've hit on the var before. Does anybody want me to go into LINQ any further than that?
Talk about the lambda functions again.
Yeah. Yeah, so lambda functions are basically just standalone. I mean, they are actually functions, so they're the functional part of C#. C# is not a functional language, but it does have functions. They don't belong to a class. They're just standalone blocks of code that can be executed at any time. So you could say, I think it's, let me find out what it is. Log. Oops. Still thinking in the wrong language. Oops, wrong one. And then I'm trying to think of how I gotta. Yeah. I can't remember how to do that. No. I can't remember how to do that now. Either way, you can't assign it to a Lambda function to a variable. Let me look that up because I want to actually show that to you for whatever reason. Oh, there we go. That works. It cannot be used in this context. Does it work? Okay, that's what it was. Oops. I don't remember. Son of a bitch. So we're defining that we take a string as an argument, we're returning a string, and then this is the name of it. So then if we wanted to so we're executing this block of code here. This is basically the function signature, accepts a string. This is the variable name for that string. And then we're just simply returning the string that you sent it. So if we did print, obviously this isn't practical, but it's just demonstrating. So if we say write line, and then call this function basically, not basically, we are calling the function the same way we normally would, is a function. So let's just make this more clear. It's the name of the variable, my lambda. That variable is holding a function. We execute it like we normally would with the parentheses right after the variable name and passing it a string of some string. So we could also say return, to really demonstrate this, we could say return plus you can see we get that appended to it. Obviously, if this wasn't being executed, that wouldn't have happened. What's up?
Something that you would find inside of a method?
You could. I don't generally define Lambda functions like this. They don't generally get defined like this and executed. I don't generally do that. I don't. Do you normally define them and store them in variables and execute them?
Yeah, no, it's usually passed into either like link or into an event handler for button clicks, or you receive some asynchronous data and you want to just do some quick manipulation and send it somewhere else.
Yeah, I don't usually do it like this. This is more just to demonstrate that this really is a function that can be stored and just referenced to. It doesn't belong to anything. It doesn't have to be instantiated. It's not static. It's actually a block of executable code that's just pointed to in memory. So that's all it really is. So when you call like a link, like sort by, it's got the sort algorithm. So for each item, this is going to be pseudocode. I'm not writing the actual thing in some list, and it's gonna it's basically going to say if some condition is true, and that condition is going to be based on like the lambda that's passed into it. So it's going to take your lambda function and say that lambda, and then pass it in the item, and then based on that result, it's going to either put it at the beginning or the end or before or after. So that's all that key is basically saying it's going to call your function and then look at that value that you passed in there with the lambda function, and then or look at the value that's a result of your lambda function that you passed in and use that to sort. So with the sort method, it's just using the key. That's why you return the key in there. So it just calls your function, and whatever value comes back, it uses that to determine what to do next. So that's the benefit of it. So you could write any number of really complex functions and just send it in there as a lambda function for whatever algorithm you wanted to use to sort by. So if you wanted to do something like, let me get this back to the loop. Yeah. So if we wanted to do that, you could also do that. It's just going to use the length of that value in order to sort, and we'll get a totally different result. Or you could do some other complex now you have a totally different, just happens to work out the same as the normal one, but it's basically taking the value or the length of your string value, adding it to the actual number that's stored in the key, and then using that as the sorting value, the value to determine whether it moves up or down in the list. And it doesn't have to be this simple either. I mean, you could wrap this in braces and write it out and have some big, I mean, really, if you're going to pass a lambda function that's like 20 lines long, you should probably just reconsider what you're doing, or how you're doing it, rather. But then you could put multiple lines and whatever you wanted. That help? Cool. So the var keyword, we went over that a little bit, but basically this is all it is. So if we do item n, so this basically just means figure out what the type is going to be. So it will implicitly figure out that this is going to be a key value pair. Let's see if it does it. You can see right here, actually, that it's determined that it's going to be a key value pair of int string, which is what we store in the dictionary. It determines that based on the context in which it's used. So if we said figure out that that's going to be a program class or an instance of a program. So this isn't really allowing you to store anything you want in this variable. It's just saying I'm not going to declare it explicitly here, and I'm going to let the compiler figure it out. Because once this actually compiles down, this is no longer a flexible type, I guess, if you want to call it that. At that point, once it compiles down, it is explicitly an instance of a program, and this is explicitly a key value pair. It's just not in your code. But it makes it a little easier when you have things like this and you don't want to write out key value pair and string. You can just use var and have it figured out. It also makes it easier if you have something that's going to be a class or a subclass of this. Like you have two different things that are going to be like, one's going to be, I don't know, some interface that implements the same methods that key value pair does. And at some point you refactor the code. You don't have to go back and change all these explicit declarations here. You can just change the type, and as long as all the other code after that still works or still has, if the new type still has same methods and properties that you call, then you'll be fine. So var basically just says you figure it out. There was a brief mention of POCO. It says here that it wants me to go over that, which is just plain old. I've seen it in two different things: plain old CLR object and plain old C# object. But basically all it is just this. It's writing your own stuff rather than allowing the framework to generate all the code for you. It's just you writing your own class. So a lot of the models that you'll write won't be generated by the .NET framework or the IDE. It'll just be you writing a class somewhere to store some information. And that's what POCO is. I've honestly never referred to it as that. Jake, have you ever said POCO before or mentioned plain old C# objects or CLR objects? Yeah, I don't. I mean, I guess it's good to know what it is, but don't really say it in everyday talk. And all right, so we went over this before too. The model versus the view versus the controller, right? Now we're starting to get into examples in the prep work that really break it out. You start to see how all of these things fit together. The model is the structure of the data and, excuse me, and does all the heavy lifting for manipulating that data. And the view is it's just there to present that data, and the controller is the go-between between the two. So the whole point in the model is just to define how the data is structured, define methods that interact with that data, and change the data. So if you did the prep work, then you'll see, let me close this. They added the cheese data and the cheese. So you've got this is just a model that stores what cheese is and things that tell you how to interact with the cheese, right? So this one just has a constructor, and then it has some public properties, name, description, and then a private ID that's just used internally. Here's another model. This is the one that's actually used to store all of the data. So this one actually has all the methods to add, remove. Did everybody do the prep work, by the way? I mean, I shouldn't really be showing you too much new stuff here. Does anybody have any questions over what they did here when they separated it out between the cheese model itself, the cheese data model, and then interacting with both of those with the view and the controller? I mean, don't be embarrassed if you need any clarification. You all are pretty sharp, though. You guys are picking up this stuff pretty quick, so right on. But yeah, it's just separating out responsibilities. This manipulates the data. The controller grabs the data, sends it to the view, and the view sends it to your browser or to whatever is actually requesting the data. Everybody's probably heard the term refactoring before as well. Refactoring just means to go back and change your stuff. That's really what it is. But you'll do it a lot. But it's always good. Well, no, I won't always say that. You don't use always and nevers. But it's generally a good thing. And you generally feel better about it because you're further along in your in your project, you generally know what the requirements are, and you start to see the problems with the original way that you wrote it. So when you go back and refactor stuff, so it should be better and cleaner than it was originally. If you go back and start gunking everything up, you should probably think about undoing your refactoring, because it really shouldn't have to. It may become more complex, but it shouldn't become harder to manage. And then they went over model binding as well, which was something that their framework does fairly quickly and easily, automatically. So like right here, we got our cheese IDs. Here, we can change our add. Before it took just a name and added that to a list that was stored in the controller. Now we've moved that into a model, an object, a class that can store a name and a description. It has an internal ID, so you can manage everything. And rather than just passing the string name and then the string description, you just tell it it's a cheese class, and then it automatically does the binding between the cheese model and the values that come back in the form. So it looks at the names of the fields in the form and looks at the names of the properties and fields in your class definition, and if they exist, it just assigns them. So if you remember from, he went over this, I think he actually did, pretty sure. So it basically just says, when it does the model binding, it'll say like cheese new cheese equals new cheese, and then it'll loop through each property and say cheese name equals, it's, again, I'm just doing pseudocode here. Actually, we might as well. Quest dot name. And it does that for a description as well. So just, it uses, it looks internally to the class to match the name of the properties or fields to the form values that you're passing. So now we can just say this is a cheese, pass it, it automatically casts it to a cheese, instantiates the cheese, you add it to your cheese list. Then you can deal with everything as objects. You don't have to worry about all the request parameters coming in. And the other nice thing about this is if you submit this as a post or get or whatever, as long as those parameters are there and they can be transferred into that object, then you're good to go. It doesn't matter. Does everybody understand how this works? This ID that they defined? Again, if everybody did the prep work, this should be, like none of this code should be new, really. You should have seen this in there. But really all it's doing is anytime you instantiate this, I did a little bit different than he did. He had one instantiation method. I had two because I wanted to pre-populate my data without having to call it in a loop somewhere. So here it accepts a name and a description. It sets the name and the description and then also calls the base constructor. So anytime this is called, it just simply assigns its own internal ID for that particular instance to whatever next ID is set to. And then it increments this. Since this is static, this is going to increment every time a new cheese instance is created. So this will just constantly increment every time through the rest of the program until you shut the program down. So then that way, you know, each cheese has a unique ID because this is always getting called anytime. Obviously, if you just had this up here and then you called cheese and this wasn't here, it was down here, that would defeat the whole purpose because it would only be called if you called this particular constructor. But since it's up here, it'll get called anytime once created. And then that way, when you go to delete it, you know that every cheese has a unique ID. You can be safe in choosing which one to delete because none of them have the same ID. Should be pretty straightforward. But Everybody get it? It can be a little confusing. I understand that it, especially just, since you guys are just now getting into this, seeing the whole workflow in your head may be a little bit more difficult. But you guys get it? Cool.
There was a question on East Class.
Yeah.
It's the, I've been having some problems with structures, the way where they are in C#. Trying to figure out how to share, but the finishing code, I did like want to look on GitHub, the finishing code. It has class Gs and then it's 3 properties and 1 field. The field is the next ID field. The properties are name, description, and G's ID. And then the constructor just has no arguments.
Mm-hmm.
And G's ID equals next ID and then next ID plus plus.
Mhm.
Doesn't say anything about. It doesn't have any arguments for name, description.
Yeah, because they're setting it afterwards. So that's because, oh, you mean because of the binding? How does that work? If there's no, or
Well,
what?
it's like, how do you instantiate G's when you don't get any or
Empty parentheses, and then you set it afterwards. I mean, these are public properties, so you can set it at any time from outside of the class. So as long as you have an instantiated cheese object, then you can just call whatever that variable name is, .name, and set it then. So you would call new cheese, open close parentheses, and then whatever .name equals, whatever .description equals.
yeah, so then they go to the cheese controller,
Mm-hmm.
new cheese, and then they're taking cheese and argument. But there they just call cheese data.add new cheese.
Yes, because they're doing this right here, right?
Yeah, and then there's, okay.
Yeah, so this is,
Behind the scenes, but
no, it doesn't accept it. So this is basically doing the same thing that I just described. So it's not, because you can also do this. So we don't get any errors or anything. So there you're instantiating it and assigning those internal properties all at the same time, which is basically the same thing as doing that. And then doing which is the same thing that the data binding is doing. So the only thing that it needs for that data binding to work is the base constructor that accepts no values.
seems like there's about 5 different ways to do constructors and fields and properties. It's hard to consider a best practice or the simplest version that.
There's not really. There's different combinations of some things, but it's still the same. Like a field, you don't have getter and setter. That's it. I guess the difference is that you could assign a value, or you let it use its default value if you're assigning a field. Properties do have a getter and setter. You can exclude one or the other, or set the access level of one or the other, or set an implementation for one or the other. But still, the thing that makes it a property is the fact that it has a getter and setter explicitly defined.
And if you have a property, you don't necessarily have to specify that it has to live off the back in the field.
No. No, because it could do any number of things. It's just a property that has a getter and setter. However those things work is up to you. You could have a field that it stores its value in, but
You don't have to put it in there if you don't want to.
no. So if you define the, if you override the set, then you do need to store it in a field. But if you leave the set alone, then it'll just work. So like this one is actually storing the name, but the minute I override this, First of all, it's going to tell me this is. Override that. I don't even know what we would do. There's nowhere to store the value if you override it. So
So you would, in that case, you would need to spell out like a lowercase string, like a private string, lowercase name.
something like that, yeah. I mean, it doesn't have to be lowercase, or it doesn't have to be underscore or anything like that. That's what I do as a convention, but you can't use this because that refers to the instance. So yeah, you'd need something to store it in, or you would trigger some other data manipulation on some other fields or properties. I mean, maybe it's not a stored value. Maybe it's just you're using this as basically when I set this, do these other things and set all these different values, which would probably be better suited to put that in a function or a method. But it depends on the use case. Always depends. And then with the constructor, there's, again, really only, I guess, two ways, if you want to call it that. It's the access level of the constructor, the name of the class, and then any initial variables that it accepts, any initial parameters that it accepts. And then you can put a colon and then tell it to call another constructor. Or in the case of like this being a subclass, you could call a parent constructor. Yeah, that's really it. So there aren't really too many. I understand that it feels like there are a lot of different ways to do it, but it's really just the same way, omitting or adding some, like, I mean, this is really the full implementation of a constructor. Access level, class name, parameter list, and then additional constructors to call. But any one of these being left out, other than the access level and the model name, is totally valid. Or class name, object name, not model name. Does that help?
Yeah.
Okay. Anybody else? Did anybody get hung up on anything in the prep work? Jake, do you feel like I missed anything? Or you even really listening? I know you're kind of busy right now. Yeah. Okay.
When you said that, I didn't hear anything that sounded long enough.
Okay. Okay, cool. Right on. Because that's pretty much it. I mean, we've hit all of these things at one point. So I'd rather just get started and you guys focus and talk and work with your TFs and start getting into it. Cool? All right, cool. Right on.